All right, hello class. This one's going to be all about cost curves. So behind me, you see the table for the cost curves. We're going to kind of walk through how what each one of these tables, each one of these columns in this table, what it really means. So I'll start off here on the far left-hand side. We have the output number of boxes. It's supposed to be, this is from the same work we did in class, number of yo-yos, but here's the whole answer key for it. So as you produce more, we have our total fixed costs. So a few things you kind of know about each one of the things I'm going to be asking about is where each one of these values comes from and why it's whether increasing or decreasing, what kind of has the shape it does. So total fixed costs for yo-yos. Actually, I'm going to switch over to making pizzas. I like pizzas a lot more, a little better example. Total fixed costs are kind of your upfront costs. What is the total amount? It's not going to change. You're keeping in the short run. We're keeping our plant size the same. For the pizza business, it's going to be $40 worth of rent and maybe a loan that I took out from those rental type things. Whether producing one pizza or 10 pizzas, it's the same. The total amount of fixed cost is the same. It's consistent there. What changes though is our variable cost. I see at one pizza it costs $10. At 10 pizzas it costs $90. That just means I need more ingredients to produce 10 pizzas than I do for one pizza. So with I need $10 worth of cheese and pepperoni and dough, kind of stuff like that for that first pizza. The more and more I produce, I need more inputs into my production process. So the more inputs, increasing that amount, that's what's making this number increase. So what this value of 30 means, in order to produce a total of 5 pizzas, I need $30 worth of ingredients and other kind of input costs to make that pizza, to make all 5 pizzas. Total cost now, this fourth column, it's going up as well. It's one way to think about it, it's the addition of the second column and the third column is the total amount of costs, our fixed costs, like our rent, plus the cost of ingredients, the total amount that it costs. So this $70 here for 5 pizzas, that $70 means it costs a total of $70 to produce a total of 5 pizzas. That includes the rent, that includes my ingredients, all my inputs, all that. All I need is $70 to produce that amount. I usually think that typically students get these first 4 columns. Okay, yeah, we're producing more, fixed, variable, I need more inputs. And it's kind of the shape of this is then the addition of these two. So it's kind of changing by the same amount that the variable cost curves are changing. Now when we get over here, it starts getting a little more confusing. When we have our per unit costs. So the first one, marginal cost. Equation, it's the change in total cost divided by the change in quantity. You see that up here. So change in total cost, one to the other, divided by the change in quantity. Typically, I'll have the quantity change by 1 most times. It's possible it's not going to be that way. But typically, most of the time, we're going to see the quantity change by 1. So we see marginal cost. It decreases to 5 units and then starts increasing again. So what kind of questions, what does that marginal cost mean? In class I've been trying to explain marginal cost as that is the per unit cost, how much it costs for each unit of output. Putting it in numbers, let's see how that makes sense. For the second unit of output, $6. Well, what is this $6? What does that really mean, having this $6 value? Where we got that amount from? It's the account of just that unit. So to go from 1 unit of $50 total cost, in order to produce that second unit, our total cost went up to $56. So from 50 to 56, that shows us that jump for that additional unit. That's how much that additional unit costs, $6. To make that third unit, we go from a total cost of 56 to a total cost of 61. So in order for that third unit, that is $5. So we increase our unit change of 1 here, change of $5 here, marginal cost. Now the reason why it decreases down to 5 and then increases again, I'm saying one of the first things we did in class was learning about marginal product. And we learned about specialization. Well, in the production function, that's all about how well you can make your inputs into outputs. So the more specialized, more efficient we are, the better we are at making our inputs into our outputs. So we had the example of the chain links and the number of workers we're changing. We're more specialized and efficient up to a certain point with the number of workers with our chain links, and it becomes less efficient when we have dimensional marginal product. So inputs and output, how efficiently that works. Marginal cost looks at the cost of those inputs. So the connection is, if the inputs to output connection is more efficient, wouldn't it make sense that the marginal cost goes down? Since it's more efficient, it should be less costly as well for each one of those units. So for a certain point, yes, it is less cost, more efficiency. That's why this number is going from 10 all the way down to 4 here. But the same thing we had in our links experiment, we start to have too many cooks in the kitchen, a number of inputs to outputs that is not as efficient as before. So the cost of inputs, whether workers or anything else, starts to increase, and it's not as efficient as productive. That's why our marginal cost is increasing here as well. All right, so that is marginal cost. Now let's look at average fixed cost real quick. So one way we know total fixed cost is $40. Now when we look at some of these averages, that $40 now is going to be spread out between everything that's being produced. I like using the term kind of more the idea of having that spread out. On average, a typical unit costs how much? It's spread out over all of that. So for 4 units, that $40 is spread out over 4 units, and it's $10. So it's roughly going to be $10 for on average for 4 pizzas. It's going to be $10. Oops. Then back up. I'm back up here. So we're going to see here as it pops back up again how the average is always going to be decreasing. Average fixed cost, asymptote, the x-axis. So the more and more we add at 10 pizzas, it's going to be $4 because that $40 is now spread out over the production of 10 pizzas. We can kind of say, all right, to produce all up to that point, that $40 is now spread out over everything. So now average variable cost, similar type idea. This $7 means on average for 3 pizzas, I have $7 worth of ingredients on each pizza. Now, it might be a little bit different per each pizza, that's true, but I'm looking at not just individual pizzas, I'm looking at the bigger picture of, for all 3 pizzas, on average I have $7 worth of ingredients, and that also has $7 also for maybe workers as well. But that's one way to think about it. For 6 units, 6 pizzas, on average I have $6 of ingredients on each pizza. So not just that individual one, but on average, it's spread out because we have our total variable cost of $36. This is increasing as we produce more ingredients. As we increase, that's going to be spread out along here. Same thing happens with ATC now. The total amount, let's say $16.50 for 4 pizzas. Now that's $16.50. The total amount is $66. So on average, our typical pizza will be $16.50 for up to 4. So it's not saying exactly how much each one is, but on average for the first 4, we get to spread out this value over all 4. Now the reason I'm using kind of that spread out terminology is because that gets into the significance of the marginal cost. Because how this $70 is spread out over all 5, 14 on average, 14 for each one. That change, the marginal cost, will then also affect this. So that connection between marginal cost and ATC. So if we have from $66 to $70, the marginal cost is 4. That $4 is then added to the total cost, which is spread out over everything. The next amount, $6 is our marginal cost. The total cost went up. That $6 addition to our total cost, we throw that in there, and that gets spread out over all of it. So having that one little input spreads it out here. Makes it, our numbers go down, down, down. As long as marginal cost is below ATC, it's bringing it down. That's the same example of your GPA and your test grade. If your one input of a test is less than your average for that class, it'll bring down your average. Or when we see down here, if the input is greater than the average, it'll bring up the average. So that's why we have ABC is the same reason. That's why these two curves are U-shaped. We typically have a Nike swoosh symbol with marginal cost and average fixed cost asymptote to the x-axis. All right, so hopefully this is a good review. Maybe make some connections as well. Be able to know what this $5 means or what this $14 means. What's the significance of those types of values and numbers? And you're ready for your test. All right, see ya.